Alright, so in this class, we are going to continue our discussion. It's still on the chapters of predicate logic. On the last two classes, we already see how we can make a translation from verbal statement into predicate logic expressions or predicate logic structures. And then also we already discussed on how to do the proof sequence on predicate logic, including the 4 new rules in proof the sequence, which is two rules to strip out and another 2 rules to insert the quantifiers. So today class we are going to discuss about temporary hypothesis. So before I explain what is that temporary hypothesis, let us go through the examples. This temporary hypothesis will be useful when we do the proof sequence. So that will be easier to explain and to demonstrate to you how this temporary hypothesis works. Okay, so let's just have this task to prove the argument Px implies for all y qxy, and this is one statement which implies to another statement for all y px implies qxy. Alright, so if you observe the formula, or the predicate expressions here, the changes, it happens on the qualifier. On the hypothesis part, we have this for all y over here. When it comes to the final statement, it moves to in front over here. So how are we going to do the proof sequence to validate whether this expression is valid or not? Okay, so as always, the first step, we will list out all the possible hypotheses, which in this case we only have one over here. Px implies for all y qxy. Now, without further saying, if you try to figure it with only this one hypothesis, how we can have the final statement which just about to move out or this quantifier in front instead of in the middle like this. So there is no way we can do this. If you try even to check on the formula tables, regardless it's on the equivalence rules or inference rules, there is no way to do this. There is no way we can get a way out on how to solve this problem. So in order we can do, this is how temporary hypothesis comes in. So in order this can work, so what we need to do is, of course, we need to understand that we must be able to have this out from the structures. In order we can have this one out from the structures, what we need to do. So we need to eliminate the px first. So we need to eliminate this one. Eliminate. How we can eliminate px? So one way to think of by using, of course, the rules. In this case, we might think about inference rules. I would like to say modus ponens, for examples. Remember, when we have modus ponens, A implies B, and we have another A. So if we implement modus ponens in this case, we can eliminate A. Then we are going to have, in the end, is B. Now in this case, as our problem over here, we don't have px. In order we can eliminate px on these hypothesis structures. This is where we need the temporary hypothesis. So the temporary hypothesis here is the one that we need, which is px. Alright, so now we already have the temporary hypothesis. So now we can implement the rules by implementing modus ponens number 1 and number 2. Then we can have for all y qxy out from the structures now. You got that? And then, of course, next we need to strip out the qualifier. Of course, since this is universal qualifier, to strip out, then we implement ui on 3, then we will have qxy. Okay, then now what we need to do is by implementing what we call temporary hypothesis discharge. How we can discharge this temporary hypothesis, which the one that we have earlier over here, this temporary hypothesis. So to discharge this one is by implementing these structures px, qxy. Hold on. Okay, how we can do this? How we can have this one suddenly? So I'm going to explain this part later on after this proof sequence, which will be covered in the theoretical part. But this is how is it happened. Okay, we are going to look at this one later on, because these all structures, they are related to each others. So I will just put a label here first, so that later we will come back on this question. So this is number 1, this is number 2, and this is number 3. So for now, you doesn't to worry first. Let's just have this one. You have on number 2 temporary hypothesis discharge, and then you have on number 4, and then you have the temporary hypothesis discharge in here. Okay, so now after we have the temporary hypothesis discharge, now what we need to do, look at your final statement. We already have on number 5, just that we not yet have the universal y. So on number 6, what we need to do is by you implementing uz on number 5, then we will have for all y px implement qxy, and we are done in here. So this is the final statement that we need. Okay, so as I mentioned earlier, on number 2 you might be able to figure already why we put px there. So as I explained earlier, and then comes to number 5, why the temporary hypothesis discharge is as these structures over here. Okay, so I'm going to write down some explanations in here. So it says a temporary hypothesis can be inserted. So understand and try to observe the statement in here. So it can be inserted into a proof sequence. So in this statement, we are allowed to do that. So we are allowed to insert a temporary hypothesis into a proof sequence. So if we assume T, so if we assume T is inserted as a temporary hypothesis okay, which is in our example earlier, what is our T here? So hold on, our T in this case is px. So if T is inserted as a temporary hypothesis and eventually W is deducted from T and other hypothesis, okay, here we have W. So W is deducted from T and other hypothesis, then okay, before that I will get to you first. In our example, who is our W? Here, the second one, which is Q, X, Y. Okay, then the WFF T implies W has been deducted from other hypothesis and must be reinserted into the proof sequence. Into the proof sequence. Okay, it's quite it's a straightforward statement, but you might find this a little bit complicated. So let us highlight one more time. So a temporary hypothesis can be inserted into a proof sequence if we assume our T is inserted as a temporary hypothesis. Okay, so hold, we have T as a temporary hypothesis, and eventually W is deducted from T and other hypothesis. Okay, W is deducted from T and other hypothesis. Then WFF T implies F has been deducted. So this is something that, look at what happened here. We have our step 1, step 2, step 3, step 4, step 5, and 6. Okay, so we have insert our temporary hypothesis T, which on the second step here, which is Px. And then it says here, eventually W is deducted from T and other hypothesis, which is what happened here. Step 1, let me highlight, and step 2. Okay, so because these things happen already, then the T implies W must be reinserted into the proof sequence, which is the one that we did on step 5 over here. Okay, if it's still difficult for you to figure this, let me make it into a point. So hopefully that will be easier. Okay, so this is just another way to explain. Okay, let's see, we have P1, P2, and so on, regardless how many we have, is the original hypothesis. Okay, let's see, this is the original hypothesis. And then we have T as our temporary hypothesis. Temporary hypothesis. Okay, and then we have W as result of implementing rules regardless, not regardless, yeah, I mean rules here is referring to either its equivalence or inference okay, which is in these examples we use over here the modus ponens, which is inference rules. Okay, results of implementing rules with the temporary hypothesis P1, P2, and so on. Okay, and then after we did that, the next step, it's a must the formula T implies W must be reinserted into the proof sequence. Okay, so what I'm trying to say here, this is the step and process when we implementing temporary hypothesis. So 1, 2, 3, 4. The purpose is just to help us to get out from this stuck proof sequence. So when we have no way to go out from the proof sequence, so there is a way to solve the problems is by implementing temporary hypothesis. So this is the step that we have to follow. This is the method. So when we have original hypothesis, we implement all the rules way down until we finish, and when it comes to a point when we stuck, then temporary hypothesis can be inserted. By implementing the temporary hypothesis, then we will have W as the results of implementing the rules. So since we have the temporary one earlier, then the next step, we need to reinsert back into the proof sequence the formula T implies W, which we call temporary hypothesis discharge, which is happened here in number 5 over here. So on number 2 we implement, and on number 5 we discharge the temporary hypothesis itself. So it balance, because it is temporary, you only use it one, and once you use, you need to get rid. That is another word to say, which happened here on step 5. Okay, so I hope it already clear about this temporary hypothesis, and the method to do it is the one that we already write over here, number 1, 2, 3, and 4. So let's just try another problems on implementing this temporary hypothesis. Okay, so I will write another predicate logic structures here. Let's have, there is X, X, hold on ya, I missed the, not the case, there is X, EX, okay, implies for all X not the case Ex. Okay, so definitely you've been seeing these structures when we discuss about negation. So by all means this is must be valid, right? But then how are we going to prove this, that this is valid? I mean, let's just assume that we do not know about negation, then we need to prove these structures. Okay, in a way, as I said, this is definitely valid. This is rule of negation. But as for now, let's just assume that we do not know about the rule of negation, so we do not know whether this structures is valid or not, but we would like to prove it. Okay, so what is the first step? Again, we list out the hypothesis, which in this case we have not the case Ex, existential X, or there is X, Ex. Then we are stuck. We do not know where to go now. But then if you look at the final statement, again we need to get out. We need to have not Ex alone, which in this case, on your hypothesis, on our hypothesis, the not is in front here and the Ex is over the one here. So we need to make it a way in order the negation and the Ex can come together side to side. So we need to get out the Ex. Then this is how we implement the temporary hypothesis. We need temporary hypothesis, which is Ex. All right. So now we can't do EG on number 2. So what we have, when we do EG on number 2, we are going to have Ex. Sorry, there is X, Ex. All right. So what next after we have this one? Now we can't remember that this is our T. Yeah, our T. Then where is our W? Is this one, right? Because on number 2 says we have T and then we have W, which is the result of implementing rules with the temporary hypothesis and all the hypotheses there. So in this case, we implementing the EG with the temporary hypothesis. So next is what? What next that we don't have yet? Step 4, reinserted into the proof sequence. So what we have now, which is called temporary hypothesis discharge. Then we are going to have Ex implies there is X, Ex. This is our never mind. T implies W. Let me just put in bracket in order not confusing. Okay. So what we can do now? we can't implement what? Look at what we have. We have this one, and we have one over here. Okay, so what we can have? We can implement modus tollens on number 1 and number 4. Number 1 and hold on, yeah. Number 1 and number 4. Why I highlight number 2 here? So let me just get to this one. Hold on. Number 1, we have this, and we have number 4. So based on modus tollens, what modus tollens says? A implies B, not B. So according to modus tollens, we will have, implementing modus tollens, we will have not A. So in this case, we are going to have not EX. Now we are close with the final statement. I already have this one, which is the final statement. We just need to have the universals. Definitely this is UG on number 5. Then we are going to have for all X not AX. Then we stop here. All right, so I hope now you can see it, how the temporary hypothesis useful to help us get out from a stuck point in the proof sequence. Okay, so again, as this is, we know it is a rule of negation which must be valid. We know it already, so it is the way to prove it. But the other way around, definitely also we can prove, but I will leave it this one for the quiz, so you can try to look at how to do that. So if we have for all X not EX implies not the case there is X EX. Okay, so hold on, yeah. Better. So if you look at this problem over here, this is just the same problem, but we switch the positions. You can see, right? Okay, so here also we can implement proof sequence, but I will leave it to you to work on this one, and this will be included in our quiz later on. Okay, so that is all for the temporary hypothesis. On the next video, we are going to see how to validate a verbal arguments by using the predicate logic structures. So not by using the nuller or logic or common sense in there, but we try to make use predicate logic structures to prove the verbal argument. Okay, that's all in this video. Don't forget to try out these structures. As I mentioned, it will be included in the quiz. Okay, so that's all, and let's continue to the next video.